Hello students, let us discuss some of lab programs of SSOS lab, that is 17CSL68. This particular lab contains three types of programs, that is Lexandiac programs, compiler design programs and operating system programs. As we have already completed the Lexandiac programs, let us now discuss compiler design program, that is in your syllabus it is program number 3, 4 and 5. And one more thing, we have already studied the topics which are required for program number 3, 4 and 5. Let us see the implementation part. Now first one, that is third program, design, develop and implement a YAC program or C program. So we will implement the concept by using a C program to construct predictive parsing table or LL of 1 parsing table for the grammar. Grammar is also given. So I think you know about predictive or LL of 1 parsing table. That is, it is suitable for constructing a parse tree from root to leaves, that is top down approach. There are some conditions for the grammar to be in LL of 1, that is it should be free from left recursion, it should be free from left factoring, as well as there should not be any ambiguity. If the grammar satisfies those three conditions, then only it is suitable for LL of 1 parsing. So given grammar, let us assume that the given grammar is free from left recursion. As you can see over here, there is no left recursion, that is LHS and first symbol of RHS are the same, that is then there exists left recursion. But here in the given grammar, there is no left recursion as well as no left factoring. Then so here we have to construct a table manually, and we will pass the table into the LL of 1 parsing algorithm. Use this table to parse the sentence A, B, B, A. That is the problem statement. Now consider how to implement this. So this is the predictive parsing algorithm. So before applying the algorithm to the given statement or the given problem statement, first let us construct LL of 1 parsing table. So first let us see how to construct LL of 1 parsing table. So this is the grammar. What do you have to do? First check for left recursion, then left factoring as well as ambiguity. But this grammar doesn't contain any left recursion or left factoring as well as ambiguity. So directly we will go for finding out first of first production. So first of first production means first of ABA. Since the first symbol is a terminal, first of ABA is only A. Coming to the second production, B gives BB. Here also the same. First of BB is just one symbol B. And here I have used at symbol to indicate epsilon, since we don't have epsilon symbol on the keyboard. So at means epsilon. Now suppose there is epsilon production, we have to compute follow of LHS. What is follow of LHS? That is follow of B. Here B, we have to look into the right hand side. B is followed by A, small letter A, according to this production. And since B is at the end, according to this, it is nothing but follow of B. So circular dependency exists. So let us stop. Follow of B is just only A. Now using this first and follow, we have to construct a table. So let us consider row as the non-terminals used in the grammar. So what are the non-terminals used in the grammar? That is A and B, where A is our start symbol, A and B. Now column wise we have to consider the terminal symbols, that is small letter A and small letter B, which is always followed by a dollar to indicate end of the input. So row wise non-terminals and column wise terminal symbols. Later we have already computed first of ABA. So A on A, we have to fill with the entry ABA, that is A on A, that is the production ABA. Similarly, according to this, B on B is BB, okay, this production. Then according to this epsilon production, we have to fill epsilon for this non-terminal B. B on A, that is epsilon production. That is, here you have to write the production itself. So for implementation purpose, we are writing only the RHS over here. Instead of writing A gives ABA, we will write only right hand side ABA here. I think you understood. Now, what next? The string to be passed is given as ABBA, isn't it? ABBA. So what is the expected output? So this is the expected output. Here we will consider stack and input. One column is stack, another column is input. Okay, listen carefully how to implement this LL-of-1 predictive parsing table and parse the statement. Initially, stack contains the start symbol. So start symbol is A. The production with the start symbol is ABA. So I directly took ABA. So initially stack contains ABA, and one more thing here, this A is our top of the stack. Next we have B, next we have A. That is, it is copied. Even though the production is ABA, we are copying this A, last A first, then B, then first A. Means the first A we should get on the top of the stack. Always this dollar indicates the bottom of the stack. So ABA means you have to read like this, ABA. So the first A is here. Now what we have to do? Now check stack, top of the stack and the input A on A. A on A. If they are the same, then forward the input pointer to the next symbol, that is B. See here in the next line you don't have A, we are discarding that A. Okay, so next input is B. At the same time this A is also popped from the stack. So we have this B, second symbol B on the top of the stack. Next what you have to see, B on B, you have to check. What is B on B? B on B is this BB. So while copying, how you have to copy? So first copy this, and one more thing, you remove this B from the stack. Okay, then while copying, first copy this B, first copy this B over here, and I mean this B, last B over here, next B, from right to left. So that the thing is, you have to get this B on the top of the stack. See here, now B is on the top of the stack. Next continue like this. This B on B, both are same. Then pop the stack as well as forward the input pointer. So you can see this B, okay, second B, this B here, and if you discard this input symbol, this B, second B you have here. So B on B, once again the same thing, copy the table contents BB with the small letter B on the top of the stack. Here small letter B on the top of the stack, and here also B, they are same, both are same. So pop the stack, you have B on the top, and if you discard this input symbol, next input is A. B on A, see here, B on A is epsilon. Epsilon means pop the content of the stack and input remains the same. Okay, B on epsilon, what you have to do is, if there is an epsilon production, pop the stack. So B is popped and there is no change in input, A remains the same, input is same. Next consider A on A, both are same. So pop this A as well as input, forward the input pointer. Now input pointer points to dollar. So dollar and dollar. At the end, if stack contains dollar and input is also dollar, input array contains dollar, then it is successful parsing of the string. If both contains dollar, then only it is successful parsing. Otherwise, it is unsuccessful parsing. That is, using the given grammar, the string cannot be parsed. Now let us consider this algorithm. Already I explained once again. If you want to see the algorithm, yes, here algorithm. let A be the first symbol of the W in our ABBA example. A is the first symbol. X be the top of stack symbol. That is, the first production is ABA, no? So this A is the top of the stack. Now while loop, while X is not equal to dollar, you have, okay, here we have a dollar. Till we get the dollar, we have to proceed. Now first consider if X is equal to A. Yes, in our case, first input symbol is A, and in the production also A. What we have to do? This is the action to be taken. Pop the stack and let A be the next input symbol. Means in our example, B is the next input symbol. Then there are 3 else if cases. Okay, we'll consider that also. If else if X is a terminal, means here A, this is another terminal like B. Okay, then it is an error. Input is A and on the stack you have other than A, any terminal symbol other than A, then it is an error. Otherwise, one more entry, if in the table, if you have an error entry is indicated by the blank. So if on the table, if there is an error entry, then error, not possible to pass. And one more option, that is, if table contains a production like this, then output the production, pop the stack and push that production onto the stack with y1 on the top. That is, you consider B gives B, then this is y1 and this is y2. We have to push this one onto the stack with y1 on the top, means the small letter B on the top of the stack. So continue the procedure till dollar is obtained. Okay, trace the entire example ABBA. Now let us consider the program implementation. Okay. Header files, required header files. Then there is an array, 2-dimensional array, production to have the different productions, first production, second production and third production. Then 3-dimensional array table with the contents, that is ABA. Then in see here, okay, here second entry, first entry is ABA, second entry is blank, third entry is blank. So to indicate blank, just null character ABA, after that null. In the second row we have first epsilon, then BB, right? So here, okay, first epsilon, then BB, then blank. Then what is this size array? One more array is int size 2, 3 with the number of symbols present in the array table. That is, first one is ABA, so its length is size is 3. Next is null, so 0. Next one is also null, so 0. Then second row at symbol, that is size is 1. Next 2 symbols, so size is 2. Next blank, so 0. Then single dimensional array to indicate input and stack. These are the declarations. Now coming to the main program, declare required variables like I, j, k, row, column, flag, etc. Then display the grammar by using production array. Display the predictive parsing table. Okay, so this is about just displaying the whatever we require. So just trace by yourself this printf table of I, j. Okay, I am not going to explain this display function and all. Let us directly go for the algorithm implementation. Now enter the input string. What is our input string? It is A, B, B, A followed by, okay, one more thing. No, only this is the input. You have to enter A, B, B, A. Okay, so scanf, using scanf, read the input, string concatenation, input comma dollar. So the program implementation puts a dollar like this. Okay, then find out the length of input. 1, 2, 3, 4, 5. Total length is 5. Initially stack of 0 is equal to dollar, bottom of the stack, and stack of 1 is equal to A. Means we have dollar $a like this on the stack. Okay, this is stack of 0 and this is stack of 1. So initially we have start symbol. Now let I is equal to 1 and j is equal to 0. I is equal to 1 for input and j is for stack. Now this is the way how the output looks, stack and input. Then just line, if you want you can write or decorate as you want. Then you introduce one while loop like this. It's a while of 1. Next, check if stack of I is equal to input of j. Okay, I for stack and j for input. So I is equal to 0 initially, input j is equal to 1. First input is a and stack of 0 contains 1 minute. Stack of 0 is dollar and stack of 1 is a. Stack of I value, what is I value? I value is 1. So stack of 1 is a is equal to input. Top of the stack and current input are the same. Then what we have to do? Pop the symbol from the stack. Then that is I minus minus. Pop the symbol, if they are same, pop the symbol and forward the input pointer as I explained with the example. Then one more if statement. At the end what you have to check, if both contains dollar or not. So if stack of I is dollar and input of j is also dollar, then print success. Otherwise, if stack contains dollar and input is not dollar, then error. So here we are using logical AND operator, so just one condition is enough. If this one is dollar and as well as input of j is not equal to dollar, or vice versa, stack is dollar and input is not dollar, then also it is an error case. So error, printf error. Otherwise, now there is switch statement, switch of stack of I. We have to set the rows and columns. That is, if that is A, then row is equal to 0. If case B, then row is equal to 1. This is how to set the rows. According to our table, we have row A and row B. So row is equal to 0 and row is equal to 1. Similarly, how to set the columns? Columns for terminal symbols. So input, switch of input, small letter A is column 0, small letter B is column 1 and dollar is column 2. Only 3 columns we have. Now check if table of row column 0 is equal to null. Here in our case, in 0th row and 0th column and 0th value is equal to null. No, we have this one, right? A we have, so it is not equal to null. If it is null, then error. Now this case, whether we have epsilon, no, table of row means 0, column is also 0, 0, value is 0, whether it is epsilon, no, we have ABA. If that is the case, then if epsilon case, then it has to be popped from the stack and you call display function to display stack and input. But these two cases are not true for our example. So check this one. If for the very important thing happens here, for k is equal to size array row column minus 1, what is the value present in size array with the row column? That is 3, isn't it? ABA, so see here, ABA whose size is 3, which is already put in size array. Okay, so that is 3 minus 1, 3 minus 1, that is equal to 2. K is great, okay, K that is 2 is greater than or equal to 0. Condition is true. Check for the, how to check for the production or how to copy the production from the table to stack. Stack of I is equal to table of row column K. Row column K means in the table we have ABA. I think you remember ABA. The ABA with the last value k. 2 means 0. This is 0 place, this is first place, and this is second place. Means this last A has been copied to stack I. See, I think you remember, after copying the table content onto the stack, this A must be in the on the top of the stack. So first copy this A. So we are taking k value. K is 2 now. This is copied. I plus plus. I mean stack is simply incremented. And what happens? K is equal to size of row column minus, okay, k minus minus, it is decremented. Now 1. So, 1 means this value, this B is copied using this statement. Stack is incremented. K value is 0. 0 means this A is copied. Now we have this A on the top of the stack. This is what to do for production. Then after making all the arrangement, just decrement I value once to point to the top of the stack, because it is already incremented over here. Just to make convenient, this incremented I value is decremented again, which points to the top of the stack. Then call a display function to display the contents of stack and input. We'll go for display function now. Display int I and ij. For k is equal to 0, less than or equal to I, k plus plus, that is update the stack from bottom to top. That's why we are updating from 0 to I. I is for stack and j is for, I is for stack and j is for input. Then required number of spaces you can give over here. Then to update input, how to update from j to n, because we have to display the remaining input from the input array. That's why consider it from j to n. J to n. So update the input, the remaining the input. So this is about display function. This is how it executes. LL of predictive parsing tips. See, students, please trace the program from beginning to end. I have just taken the first case, that is our ABA case. Just ABA is copied from the table to stack. Then, okay, once again I will show you the table now where we are. Yes, here just ABA, it is successfully copied to stack array. Now what happened? Top of the stack A and input A has been checked. Both are same. Stack is decremented and input is incremented. That is, we are considering the next input B. Now B on B is BB. Once again, production has been copied from table to stack after popping this B from the stack. Like that it continues till the end. So at the end, the second if statement becomes true, that is if stack contains dollar and input also contains dollar, both are dollar, then you will get successful parsing of the string. This is about LL of predictive parsing table. Now one more program let us discuss in this video itself, that is data structures for the 3-address code. We have just discussed this topic in the 5th module, that is data structures or the representation for 3-address code are quadruples, triple and indirect triples. Here, according to the question problem statement, we have to consider triple. Using the triple, we have to write machine code for the given problem. So, do you remember what is quadruple and triple? Quadruple has 4 fields with the operator, argument 1, argument 2 and result, and triple contains only 3 fields, that is argument 1 and argument 2. Instead of this result, operator will be there, operator, argument 1 and argument 2. This result is indirectly considered from the index of this operator, this lines. Question, let us go for the question now. Design, 5th program. Design, develop and implement a C program to generate the machine code using triples of the statement. For the statement, this one, A is equal to minus B into C plus D. This is the given statement whose intermediate code in the 3 address form. Intermediate code is also given in the 3 address form. 3 address form means we have discussed already. At most one operator on RHS or some different types of assignment like this, unary operators like this. First statement is T1 is equal to minus B. So T1 is equal to minus B has been represented by triple form like this. We have 3 columns: operator, argument 1 and argument 2. This is the index, just index, it is not a column. Minus, operator is minus, argument 1 is B and argument 2 is null. Just to represent null, I have put a question mark over here. Okay, instead of null, a question mark means no argument. Okay, second line T2 is C plus D. So operator is plus, first argument is C, second argument is D. Third line T1 into T2, operator is star. Then argument 1 is 0 index, that is minus of B. Argument 2 is C plus D. C plus D is indicated by index 1. So 0 and 1. And the last column A is equal to T3 is implemented by like this. Operator is equal to argument 1 is A. Okay, argument 1 is A, argument 2 is T3. T3 means this index 2. Now directly we will see the program. It's just simple C program. Different header files, then one 3-dimensional array to represent this triple. Minus, it is initialized with the values minus the first value, then B, this value, and the third value is question mark. Second row plus C and D like this. Third row star 0 and 1, and fourth row is equal to A and 2. So now this array is the representation of this triple set. Okay, then machine code, how to write, this is the expected output. Machine code generated is like this. First, what we have to do, we can consider any registers, general purpose register. So first I will load register R0 with the minus of B. Then R1 and R2 I will consider with the value C and D. So I have register R0, R1 and R2 with B, C and D values. Then what to do? Addition, right? Its parenthesis expression is C plus D. So add R1 comma R1 comma R2 means store the result in R1 with the addition of R1 and R2. R1 is having C and R2 is having D. So C plus D is added and stored in R1. After that multiplication with the R0, that is minus of B, and R1 contains C plus D. So multiply R0, R1 and finally store. So result must be stored in A. That's why store A comma R0. This is the machine code with respect to this example. And one more thing you remember, this program will work for only this example. Okay, it will not work for any other example. It will work only for this example. If you want to execute other example, this triplet form need to be changed. Now let us consider the code. Here no special logic is there. Just first display the input statement, then display the intermediate code in the 3 address form, okay, given in the question itself. Then represent the triple, the table which we have discussed in the previous slide. Okay, so it is left to you can display by considering your own logic. Okay, so if row is equal to 0, then print the first row, print the second row, third row, okay, like that. Then machine code generated is one printf statement to have machine code generated. Now this is the logic actually. Introduce one for loop, row is equal to 0 less than 4. Okay, we have only 4 rows, that's why 0 to less than 4. If test of row means here we have 0, 0 and second column, if we have value question mark. Yes, 0th row, second column, we have question mark. Should I show you? Okay, 0th row, this is the first 0th column, first column and second column. So 0th row, second column, we have question mark. If that is the case, then what to do? First iteration for this if executes, what to do? Printf statement, load R0 with minus and b, isn't it? So minus means row of 0 and b means row of 1, 0 and 1. 0th row, 0th column and first column, isn't it? See, 0th row, 0th column we have minus and first column we have b. So that's it. First line is completed. Load R0 comma b is completed. Now what happens? This if then next we have else and all. They will not be executed because we don't have that particular entry in 0, row 0, column 0 and value 0. First symbol of the table value, it is not plus, right? We have something minus, right? So this case is also false and remaining cases will be false only. So this will be executed for the second iteration of for. Second iteration of for means row is 1. Okay, row value is incremented, so row value is 1. So first row, 0th column and the value is plus. Yes, we want to see first row, first column, 0th column and the value is plus. Yes, this condition is true. Then what to do? I mean, addition means first we have to load R1 with C and load R2 with D and then add. These are the 3 statements which are going to be taken place. In the array T set, row is 1 now, column is 1, we have C, and next column we have D, C and D. So load R1 comma C, load R2 comma D will be printed. Then add R1 and R2 will be printed. Then this is for third iteration of for. Yes, next row we have star, isn't it? So for star what to do? Only the multiplication R0 and R1. Then this is for last iteration, that is store. Finally, if all cases are false, then store %s comma R0. That is a comma, you should get a comma R0. So that is the last line. Close of else, for and all this end of the program. So very simple program, simple C program for generating machine code with the triplets given. 3 address code will be given. Triplets you have to form and then implement the program. Thank you.